Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today, our group will present a project about PSDA project, which is Students Performance Factor. So let us move to the introduction part. So basically, the dataset that we use in this project is a students' performance factors that we got from the Kaggle website. So our research aims to explore factors affecting students' exam performance, especially relevant to university students. We use 4 tests in our project, and the first one is a 2-sample hypothesis test. We use this test to investigate if gender affects exam scores. We also do the correlation analysis in order to examine the relationship between study hours and exam scores. We also done the regression analysis in order to determine if study hours can predict exam scores. Last but not least, we also use a chi-square test of independence in order to perform and see if there's any significant relationship between gender and study time category. All of these analysis and tests were conducted using R programming that we have learned in the previous class to ensure accuracy and clear representation of the results. Now let us move to our dataset. So basically, what we have done in pre-processing data is that we have a total of populations that is equal to 6,608 of students, but we decrease it to use a sample of 300 students only, and we also use the confidence interval of 95%, which is equal with alpha is 0.05. We also delete the outliers and unused columns in order to achieve our goals on this project. So basically, this is our variable that we have identified from our dataset. The first one is gender. We put it as a nominal with a qualitative type of variable because we know that gender is only have 2 types, which is male and female. We also have exam scores that level of measurement is interval and it's quantitative since it is a number. Why did we choose it as interval? Because exam scores doesn't have true zero value, which means if we have a 0 marks in our exam scores, that doesn't mean that we got no exam scores. So the third one is study hours. It is ratio because if we have 0 study hours, that means we didn't study at all, and it's quantitative since it is numerical. So we divided our dataset into 2 parts, which is gender and exam scores. By using these 2 variables, we determine 2 objectives. The first objective is to determine the relationship between gender and exam scores. We used 2 test sample analysis and expected that there is no difference in mean exam scores between females and male students. The second objective is to evaluate the independence between the gender and study hours. In order to accomplish this objective, we use the chi-square test of independence, and we expect that there is a significant relationship between gender and study hours. The next part is we use the variables of exam scores and study hours. We also have 2 objectives in this part, which is the first one, to examine the relationship between exam scores and study hours by using correlation analysis. Our expected output is that we have a positive and strong correlation will be determined by calculating the correlation coefficient. And the second objective is to assess if study hours is a predictor of exam scores by using regression analysis. We expect that exam scores are dependent on the study hours. So that's all for the dataset part. Now let us move to data analysis.
Assalamualaikum, my name is MOHAMAD and I will now explain on our 2 sample tests of hypothesis. So the variables used are exam score and gender. Our hypothesis statement follows, where mean 1 or group 1 equals the mean exam scores for males and group 2 equals the mean exam scores for females. Thus, our null hypothesis states that there is no difference in mean exam scores between females and males. Our alternative hypothesis states that male students have higher mean exam scores than female students. Hence, our null hypothesis states that the mean of group 1 equals the mean of group 2, and our alternative hypothesis states that the mean of group 1 is greater than the mean of group 2. So in our R code, I will now explain these lines over here. So the first thing I did was to extract the exam scores for males and females from the dataset using this type of code. And then for our equivariance test, we needed to do this test so that we can use either two types of tests, which is firstly the normal t-test in R programming and also Welch's test. So we have concluded that the variance of male scores and female scores are unequal or different. As seen here, the true ratio of variances is not equal to 1, so we need to set the var.equal equals to false. So we are using the Welch's test over here. If it was equal, we can just use var.equal equals to true. And this is the output of the two sample t-test from this code, and I will explain in the next slide. Test statistic, we have noted that the confidence interval is 95%, so the alpha is 0.05. So conventionally, to calculate the test statistic we would use this formula, but in our R programming code, we have calculated that it is equal to negative 0.19668. To calculate the degrees of freedom, we have calculated in the R programming code as 205.92, but this is the formula that you can conventionally use to calculate the degrees of freedom. To calculate the p-value from our R programming code, the p-value is 0.5779 as seen over here. So in conclusion, we have used the 95% confidence interval. The test statistic is negative 0.19668. The degrees of freedom is 205.92. The p-value is 0.5779, and the critical value is around 1.652, which is taken from a one-tailed t-test at alpha equals to 0.05. So the calculated test statistic is much lower than the critical value, which is here. This is our test statistic. Negative 0.197 is lower than our critical value, 1.652. So we fail to reject the null hypothesis. So in conclusion, there is no sufficient evidence that male students score higher than female students.
My name is MOHAMAD. Today I want to present about correlation test. So correlation test is about to determine the strength of a linear relationship based on the R value. Okay, so the first figure is our result from coding in R programming. The variable that we use is for dependent variable is exam score, and the independent variable is study hour. So the dependent variable, which is exam score, will depend how is the study hours. Okay. And for the null hypothesis is we state that no linear correlation, which means that zero correlation, which means that both variable is not does not have any relationship. Okay, so for the alternative hypothesis, we state that linear correlation exists. So whether it is negative correlation or zero correlation or either positive correlation. Okay, so for test statistic value, so for the R value we got from the result is 0.397, which means that this value interpret that it is a positive but weak correlation. Okay, and so from the R value we will get the T value. So the T value also is given from the result in our R programming, which is 7.45. So the T value, we will use the T table to get the P value. Okay, so the P value we got here is very small, which is 1.0 times 10 power of negative 12. So from this value we will compare to the alpha value. So the alpha value that we use is the standard, which is 0.05. So when we make the conclusion, we reject null hypothesis because the test statistic value is less than the alpha value. Okay, so based on the graph, we can state that it is a positive relationship because it is from down to go up, and then it is a weak relationship because there is not that is far above beyond the line here, so it is a weak relationship and positive relationship. So for conclusion, we conclude that linear correlation exists, which means that there is a relationship between two variables, and it is weak and also positive relationship. So before this is correlation test. Correlation test is to find the strength of relationship between two variables. So for this test is chi-square test of independence. So this test is to search for if there is a relationship between two variables. Okay, so the variable we use is, the first one is gender, and the second one is study hour range. So this study hour we divide into three categories, which is high, medium and low. Okay, so for the null hypothesis, we state that variables are independent, which means that there is no dependencies between both of the variable. And the alternative hypothesis, we state that variables are dependent. Okay, so the test statistic, we got X score is equal to 0.671 from the our result from the R programming coding here on the right hand side. So X square value is equal to 0.67186. Okay, so for the p value we got from the X square, we will use the chi-square test table, but we don't use it because there is the result from the programming, which is 0.7147, so 0.715. So we will compare this p value with the critical value. So the alpha value here is 0.05. So for the conclusion that we can make from this is we fail to reject null hypothesis since the test statistic value is greater than the critical value. So 0.715, which is the test statistic value, is greater than 0.05. So we fail to reject null hypothesis, which means that we accept the null hypothesis, so the variables are independent. This means that there is no significant relationship between gender and study time category. Thus, the variables are statistically independent.
Now we move on to regression test. So for this test, we use two variables, which is exam score and also study hour. So the exam score will be the dependent variable, and for study hour, it will be independent variable. So we follow like the step on the slide. So the first one, we calculate the estimated regression model. So this is the equation for estimated regression model. Y is equals to b0 plus b1x. It's same like the linear equation. So we need to find the value of b0 and also b1. So this is the equation. This is the least square equation. If you are calculating it by manually, and then we just calculate it by using RStudio software, and then the output is here. So for our B0 it will be 61.9158, and for our B1 it will be 0.2639, and then these two value we substitute on our equation, and our final equation will be this one. And then next is explain and also unexplained variation. So this is the explanation. SST is total of sum of square, SSE is sum of square error, and SSR is sum of square regression. So for this one, we also use the RStudio software, and then for output, SST is 4603.512, SSE is 3878.104, and for SSR is 725.4079. And then coefficient of determination. So for coefficient of determination, the equation is this one. So we just use our previous value for SSR, sum of square regression. We just divide it by total sum of square, and then we will get the value. We also use the RStudio software, and the value that we get is this one, the bottom one, which is 0.1576 behind at the right side of the multiple R square. So based on this value, we can conclude that only 15.8% of the variation in exam score is explained by variation in study hour. And then we calculate the standard error of estimated. So this is the value, and the standard deviation of regression slope, the equation is this one. So both of this equation we also calculate it by using the RStudio software. So for standard error of estimate, we can see the value just right side of the residual standard error, which is 3.614, and for the standard deviation regression slope, we can see here 0.3541. And then lastly, for regression test, we can test it for the t-test. So for the initial step, we state the hypothesis, the null hypothesis, and also the alternative hypothesis. So for our null hypothesis, it will be no linear relationship, and for H1 alternative, it opposite like null hypothesis, which is linear relationship does exist. And then we calculate the test statistic. So for test statistic, this is the initial equation. If we are calculating it manually, but we use the RStudio software, we can obtain the value by looking at this one, 7.453, and then we obtain the value, and then the critical value, we find the degree of freedom n-2. So our sample has 300 data, so we get our degree of freedom is 298, and our alpha value is 0.05. And then we take a look at t-table, and we can get the value of 1.960. So we have two value, and then we just compare these two value, and then we can make a conclusion. So our conclusion is that our test statistic is greater than our critical value. So we reject our null hypothesis. Therefore, we can conclude that there is enough evidence to support that a linear relationship does exist between study hours and also exam score. That's all for regression test.
Okay, now last but not least, we've come to the conclusion. So what that we can conclude is the two sample hypothesis tests showed no significant difference in exam scores between male and female students, indicating that gender does not affect performance in this dataset. Which means if we think it logically, in order to perform in exam, it's by your own effort. It's not about the gender. There's no gender bias in performing on the final exam. So we also have correlation analysis that we calculated and analyzed. It's revealed a weak but positive linear relationship between study hours and exam scores, suggesting that increased study time slightly improved performance. Other than that, regression analysis produced the model y equal to 61.9158 plus 0.2639x, with the r squared is equal to 0.1576, meaning only 15.8% of exam score variation is explained by study hours. A chi-square test of independence found no significant relationship between gender and study time category. showing that these variables are statistically independent. So overall conclusion that we can conclude in our project is that while study hours have some influence on exam performance, gender has minimal impact, and other factors not measured in this study likely play a larger role in determining exam outcomes. So, thank you for listening to our video, and hopefully you have a nice day. Bye.